In this section, we are taking a look at the ratio and root tests. So these are our last two tests for convergence and divergence. And in using these tests, before we take a look at the tests or work any examples, they have a lot to do with limits. So we want to recall some limit rules. So we have the growth rates of sequences information of some sequence ratios to watch out for limits being 0 or infinity. And we also have some limits of E to watch out for. So just review those before we keep going into these tests. So first, we're going to look at the ratio test. And the ratio test says that if we have some series of a sub n, the ratio test tells us to look at the ratio of the n+1 term over the n term of the sequence and look at that limit. That limit's going to come out to some value, assuming this test is working. And what we're going to compare that limit against is 1. So if the limit is less than 1, then the series n equals 1 to infinity of a sub n is absolutely convergent. If the limit as n goes to infinity of this absolute value of the ratio comes out to a value, and that is bigger than 1, then the series is divergent. And if the limit n goes to infinity of a sub n+1 over a sub n comes out to be 1 exactly, this is a case where the test is inconclusive. Or the ratio test doesn't work. So not a lot to check, we just need to look at the limit of the ratio, and it can tell us either it's completely, absolutely convergent, or it's divergent. But in some cases, the test doesn't work, and we need to use other tests. And most of the time when this ratio test is inconclusive, one of the things we might want to look for is the comparison tests. Now, a few notes on the ratio test. 1, the ratio test cannot prove conditional convergence. Notice either it shows absolute convergence or it shows divergence. It doesn't show conditional convergence. So the ratio test cannot prove something is conditionally convergent. Second, we have these cases where the ratio test is inconclusive. Well, Just like there's some series that don't work well with the ratio test, there's some that would work very well and what we should be looking for. And that is the ratio test works really well with exponentials. Like, say we have 3 to the n over n as our series. The ratio test would work really well on this because of that exponential piece. The ratio test also works really well with factorials. Almost to the degree of if you see a factorial, the first test you should try is the ratio test. In fact, it is the test you should try first. And as a review, what is a factorial? Factorial is that notation with the exclamation point. And what factorials mean is we're taking that number with the exclamation point, so n, and multiplying it by all the numbers before it, all the whole numbers, because this is a sequence. So n times n minus 1 times n minus 2 times n minus 3, all the way down until we multiply by 1. Notationally and mathematically, we define 0 factorial to be 1. And some other examples, things like 5 factorial would mean 5 times 4 times 3 times 2 times 1. Or something like 2n plus 1 factorial means 2n plus 1 times 2n plus 1 minus 1, which is just 2n. Subtract 1 again, subtract 1 again, and continue on until we multiply all the way down to 1. So we'll be working with factorials. We'll be seeing those growth rates and exponentials and limits of e coming up. But we will take a look at examples of using this ratio test in the next video.